In the approach to process modeling I'm demonstrating in this course, I'm using classes to represent business objects such as customers and stations. When you create an instance of a class, you can add that instance to a collection of objects. In this movie, I will use a for next loop to move through the objects in the stations collection to calculate processing times. I'll use other techniques later in this course, but I wanted you to see how for next works in this situation. My sample file is chapter 0205, and that's a workbook you can find in the chapter 2 folder of the exercise files collection. We have already read in information about the number of stations and their mean and standard deviation processing time, so we can now go over to the Visual Basic Editor and create code that will use that information to calculate processing times. I'll press Alt F11 to move to the VBA editor. Now that we're in the Visual Basic Editor, I can scroll down to the bottom of the Module 1 code module, and below the step through stations using a for next loop comment, I can enter the code that will do exactly that. We need to move through each of the stations, so I'll type for LST counter, and that is the station counter variable for this type of for next loop, equals 1 to L number of stations. And enter and tab over. We'll just work with one customer in this case, so I'll do customers, left parentheses 1, period station. So the station property equals LST counter. In other words, we are setting the customer's current station to the counter variable. Enter twice, and now we can generate a random processing time. So I'll comment that for documentation. And enter. This will be a single precision floating point random number. So I will use my SNG rand variable that I declared earlier, equals RND, which is a built-in function, and left and right parentheses, and enter. Now we'll use that random number to generate a time that a customer spends in a station. So I'll type LSTA time equals application.worksheet function period norm underscore INV. So we are using the inverse of the normal distribution. What that does is it uses the mean and standard deviation to generate a random value within a distribution with defined characteristics. So I'll type a left parentheses, and SNG rand will be the X in this case, then a comma, then stations, left parentheses LST counter dot STA mean. So we're taking the average processing time as the first argument, then a comma and a space. Now it looks like I'm going to run out of room. So after the space, I'll type an underscore and another space and enter, and space in a bit. The pattern of space underscore followed by another space lets you wrap a single line of code onto a second visible line within the Visual Basic Editor. So everything I type after this will be considered part of the code from the line above it, except that now it will all fit and I don't have to scroll left and right. So then we have stations, LST-CNTR, followed by right parentheses. So LST-CNTR is within parentheses. It indicates which station we're looking at. Period, STA-SD, so it's standard deviation, and we'll follow that with a right parentheses. Okay, I think I got all my parentheses right, so I'll press enter a couple of times and go back over. Now we'll write the processing time. For now, we will write it to the immediate window, so we'll use debug.print. So I'll do write processing time, period, then debug.print. And we'll make this a little bit easier to read by adding some text. So in double quotes station and a space, then close the double quotes, and ampersand to concatenate stations, LSTCNTR, in parentheses, period, station ID, STA ID, so the station ID property of the station we're looking at, and then in quotes a space, time, followed by a colon, and a space and a double quote, then another ampersand, and we will give the time. So that is LSTA time. And enter and backspace. Now we need to close the station counter loop, so I will add a comment to document that, and next. So what we have is code that will generate random values for each of our stations. Everything looks good. If I'm going to run this, it's going to show the results in the immediate window because I use debug.print. To display the immediate window, I'll press Ctrl-G, and then I will click back in the body of the code and press F5 to run it. And we get station 1 time of 20, station 2 of 10, and station 3 of 16. If I go down to the immediate window and delete those values, click back in the subroutine and press F5 again, you'll see that we have different random results. And that is the key to an effective and useful simulation.